Welcome to everyone for joining us today from around the globe. I gather from at least 3 continents. I am Satinder Gill, speaking with you from Cambridge, and it's a great pleasure to have you with us for this second of 3 webinars on art, AI, and everything else. The Nabi Atscentre in Seoul is the main host of this event. The centre is celebrating 2 decades of its foundation by the remarkable Seo Young-ro, whom I had the pleasure of meeting in Cambridge just over a year ago. And what a different time that was in our lives. This programme of webinars has been developed with Nikos Papazeriadis, who beautifully chaired the first webinar, from the Research Unit for Public Cultures at the University of Melbourne, and in partnership with the Interdisciplinary Research Network, CRASH, at the University of Cambridge, and the international journal AI and Society. Nabi explores how relations between art and technology can create aesthetic and ethically driven interventions to address our social problems. For example, to counter racism and to nurture emotional connection, both very salient issues of our times. We could say that the arts play a key role in questioning and reframing our understandings by directing attention to the tacit assumptions, norms and expectations embedded in all our cultural processes. Today, we're going to hear more about how they do so with regards to our perception of data, of certainty, and myth of the magic of the algorithm's intelligence and the opaque black box. There is a supposed neutrality around atemporal, disembodied, and depersonalized data and technology, evidenced in the idea that human intelligence can, in the absence of person, be artificially represented, reconstructed, and reproduced through computation. In what ways can the interplay of the arts with technology reconceive human and machine symbiosis and reconfigure what moving with an intelligence that is artificial might be like in new entangled realities? I would like to hear a quote from the engineer and pioneer of the human-centered systems movement and founding chairman of the AI and Society journal, Mike Cooley, who in his book, Architectural Bee, famously opens with this quotation: "The bee puts to shame many an architect in the construction of its cells. But what distinguishes the worst of architects from the best of bees is namely that the architect constructs in his imagination that which he will ultimately erect in reality. And at the end of every labor process, we get that which existed in the consciousness of the laborer at its commencement." It's a very important quotation. We all have imagination and creativity. As a parent, a teacher, neuroscientist, a nurse, a bus driver, a doctor, and imagination is embodied. In today's discussion, which I'm very much looking forward to, we will explore the landscapes of the entanglements of life, liveness, labor, imagination, and artificial intelligence. On practical matters, the format of this webinar is 2 15-minute presentations, and we have a response for 10 minutes. That should give around 45 minutes for discussion. I do encourage you to make comments and post questions in the chat, and I will try to keep an eye on them and do my best to bring your questions to the panel. It now gives me great pleasure to introduce our speakers. Matteo Pasquinelli joins us from Karlsruhe in Germany, where he is professor in media philosophy at the University of Arts and Design. Matteo is a tour de force in questioning and reframing our conceptions of what artificial machine intelligence is, as rooted in ideas about data and human labor. His manifesto, which I'm delighted to say we recently published in AI and Society, is called The New Scoop. I hope I pronounced that correctly, Matteo. The New Scoop manifested AI as an instrument of knowledge extractivism, with the mission to demystify AI. And Matteo will be followed by the impressive artist Sabine Himmelsbach, who directs the House of Electronic Arts in Basel. Sabine has richly explored new ways of reconceiving our relations and ways of engaging with AI, And one of the many art shows she has curated is in fact called Entangled Realities. She will share her experiences and reflections with us today. It will be a treat. And lastly, our respondent is the wonderful artist and designer, Sey Min, who joins us from South Korea. Sey Min's experimental artwork with data and its visualization carries an awareness that, and I quote, data is always partial and subject to the conditions that frame its collection. I'm intrigued about what Sey is going to say. We have a wonderful discussion to look forwards, and without further ado, I would like to welcome Matteo as our first speaker. Matteo.
Okay, hi, hello, hi. Good morning or good afternoon or good evening in any place of the world you find yourself at this moment. Thanks, Satinder, for the introduction. And I want to thank also the Nabi Center for this invitation. I think I go straight to my presentation. We don't have much time left for more friendly conversation. I try now to start my presentation that I hope you can see clearly here. I hope you see it well, correct? Fantastic. So what I would like to do with you today is very briefly, in a short time, is to go back to the history of artificial intelligence, and we will make a short adventure inside the machine, so to speak. Then I would like to say a few things about which kind of intelligence is indeed today artificial intelligence. I'm really interested in my research also to define the logical form of this AI, of this artificial intelligence everybody is talking today. And then with you, I would like to make some conclusion, or to have a conversation, to have some aesthetic and political reasoning about this new phenomenon. I think it's good to do some archaeology sometimes. We talk about artificial intelligence, but we never mention, for instance, the specific algorithms or the specific software. So I'm really a bit disappointed sometimes because we are not very precise when we talk about AI. So we use this umbrella term to define many, many things. But it's good sometimes to look back into history to see where these technologies, these techniques are coming from. And with you, I would like to start from the very beginning. So from the first sketch of an artificial neural network. An artificial neural network actually started to work properly, to give some result, because before the 1958, when Frank Rosenblatt basically turned on the electricity on his perceptron, the first operative neural network, there were other experiments, but they didn't work very well. So 1958 is basically probably the date we should remember when we have a first functioning neural network. And I'd like to show the first diagrams they were using, just to share with you this this fact that neural networks at the beginning were sort of simple. They were, you know, some kind of. I want to show this other picture of what the machine really looked like in '58. This is the first operative neural network. You can tell it's pretty large, pretty big, pretty analog. It was not really much digital. One of the implementation of the first neural network, the perceptron, was really an analog machine. You can tell here there is a big C, and then there is a sort of apparatus. This is supposed to record this C, and this letter C is also reproduced on the top part of this image over there. The first neural network was very simple. It had only 20 per 20 metrics of the retina of the first neural network was, let's say, about 400 pixels, basically nothing. But this is the beginning of the revolution of neural network that then will become the revolution of deep learning today. And I'd like with you to show these two aspects. On one side, the logical form of the algorithm, so to speak, of the computational model, and on the other side, what the machine looked like from the external point of view. Then I would say in the history of neural network, going very fast, compressing everything in few minutes, we should remember this other breakthrough, the convolutional neural network designed by Jan LeCun in 1989. And Jan LeCun is today the head of Facebook artificial intelligence. He is indeed one of the pioneers of the revolution of deep learning, and he engineered a specific architecture called convolutional neural network. This is what the machine looked like in 1989, 1992. And it was indeed a neural network designed to recognize numbers, especially the numbers on the numbers of postal codes on, that you find on letters. And then the reason why we talk about artificial intelligence today is because in 2012, Alex Grzybski and his colleagues, including his PhD supervisor Hinton, designed this very complex neural networks, AlexNet, that won the ImageNet competition. And since 2012, since the success of this technology, the one you see here, we are inside of what is the new AI revolution, but to be more precise, is a revolution run and driven by deep neural network. This diagram is very different from the first diagram we saw from 1958, and probably it's very difficult also to explain. All this number means basically layers and layers and layers of neuron. If I said the first neural network from 1958 was basically, as we said, 400 pixels, 400 neurons of the first layer, and just one basically hidden layer. Here we have hundreds of hidden layers and millions of hyperparameters to train. Today, indeed, deep learning, deep neural networks have become increasingly complex. There is a website called Microscope that allows you to go inside the neural networks to basically navigate, browse all the architecture, to stop in each node and see what's happening there in these computational nodes. And I want to bring also this example to show what the machine inside looks like today. And probably we became familiar with this sort of aesthetics of deep learning and this crazy triple-lysergic image that are used to show what neural networks today do inside. Indeed, neural networks, they became powerful machine for pattern recognition. At the beginning, they were designed to recognize very simple patterns, like very simple letters or very simple lines, as you see here on the left of this image. And progressively, they learned to recognize more complex image, to put together simple pattern. And today, indeed, they recognize complex objects because they put together complex patterns. And this is indeed an example of what Microscope, the website I showed before, does. Basically, it shows the composition of feature visualization, the composition of pattern recognition within a deep neural network. But I would like to stop here for a second and to take indeed this image, that is one of the images you find on Microscope, is one of the images that is used to show how a neural network see the world. I chose this image because I would say there is no specific reason to find another image. You maybe don't find it really interesting, aesthetically, artistically, not many meaningful, but for a machine, there is not much difference between one image and the other. So this is basically a way, for instance, a deep neural network like AlexNet that I show somehow is able to recognize, I would say, a dog. So the way machines see the world, the way neural networks see the world is pretty different from where we see. They see indeed what they produce in their computation is a sort of statistical distribution of the external input. But the way they organize the statistical distribution is completely different from the way we see it. And of course, in this gap, in this difference between how the machine sees the world and how the human sees the world, is there that, of course, we can intervene and we can play and experiment and explore aesthetic and artistic practice. But for me, this image, it is this distorted vision of reality. It's a way, as an analogy, it's a visual analogy to show how, in general, neural networks see also other sort of data. So this is a way, for instance, to just represent how a neural network see visually the external world. But when we apply neural networks to other kind of data, it could be social data, economic data, data of the stock market, data gathered from hospitals about your health, your body, probably what neural networks do is the same kind of strange statistical distortion of reality. So I just bring this image in this very short excursus to focus on what neural networks achieve in the last 50 years and where we are today. So the logical, political, cultural, aesthetic form we discuss has more or less this shape when we look inside the machine. Of course, externally, there are many other things we can consider, but I'm really intrigued by the logical form of the machine inside itself. And briefly with you, following also what was the invitation for this webinar, the poverty of philosophy, but briefly, just to frame the era of artificial intelligence in which we are finding ourselves. Which kind of intelligence is artificial intelligence? I asked at the beginning. Which kind of logical form takes AI today? Intelligence is a very generic and very general term. To make short a long history, we'll say that actually the first project of artificial intelligence called symbolic AI, or good old-fashioned artificial intelligence, that was based on deductive inference, failed. So strangely today we called AI something that at the beginning had another meaning. When we talk about deduction, it's very simple. You have to think that the original artificial intelligence wanted to automate intelligence, human intelligence, using a very static model, that is a dictionary and a grammar put together, so to speak. Then, of course, history took another trajectory. Neural networks, after a lot of problems, became successful. The so-called connectionist AI emerged with deep learning, but the logical form of neural networks, deep learning, is something different from the original project of AI, and it's based on statistical inference. And today, basically, machine learning has extended this technique, that is the technique also of pattern recognition, to any kind of data. So pattern recognition is a good way to describe what AI does today. And we should ask, as philosopher, as artist, as cultural practitioner, is pattern recognition a good definition of intelligence? Aside from this, there are other problems that are also mentioned in the invitation for this seminar. And it's the fact that basically machine learning, neural networks, they perform pattern recognition, building up statistical correlation on large data. I know that probably the term statistical correlation may sound a bit brainy, difficult to digest, but we will explain it in a second. Indeed, machine learning today, what people refer to AI, it's like a large machinery, a large statistical machinery. It's like a powerful machine to extract statistical distribution. This means, briefly, that machine learning, as Chris Anderson also proposed in his article on Wired many years ago, machine learning replaced the old culture of causation, the old, for instance, scientific culture to, try to find explanation for event, to build model of causation in nature, with an episteme, with a knowledge model of correlation. And this is an important cultural, philosophical, and logical revolution. So when we say that, for instance, we apply artificial intelligence in the science, this is true. Artificial intelligence, machine learning is a powerful tool. But when scientists use machine learning, sometimes they have strange effect, because indeed, this artificial intelligence is not real intelligent. It's only able to draw correlation. And correlation is like basically the fact that an event A is connected to an event B, but without explaining the causation, the relation between them. And you can also bring the example of climate change. You can bring the example of the migration of birds. neural network can be very powerful to predict what could happen, for instance, but they will never tell you why. Was also a remark made recently by Noam Chomsky. Noam Chomsky said, I'm not really interested in knowing when things will happen. I'm not really interested in knowing that the neural network can predict migratory routes of birds if you don't tell me why. And this is an important issue in science. This has caused strange things in science. Like, for instance, to give just an example of how indeed machine learning is an ambivalent tool. This is a news from yesterday from this researcher, Taro Makino, that has been using deep neural network to make diagnosis of breast cancer. And when neural networks are used to make this diagnosis on breast cancer data, they take decisions that are spurious, that are not based on the same kind of decision of the human eye, but maybe they discover something else. So it's interesting how they want to use neural networks to automate also diagnosis, but this is sometimes ambivalent because actually, yeah, they can be successful, but for a reason we don't know, or taking decisions that are completely or slightly different. And here we have, this is a good example of the sort of schizophrenia we have to inhabit also in the scientific world between the point of view of the machine and the point of view of the human mind. But this is as ambivalent. In other cases that also I mentioned briefly in the text no-scope with Vlad and Yoler, sometimes the application of machine learning in science, in diagnosis, in medicine, can produce hallucination, can hallucinate feature, can see things that are not there. This is my brief excursus of sort of problem that we are today with the knowledge paradigm, the knowledge model of AI. So where we are at the moment, what we could say, what is my position in relation to this strange, monstrous construction that is artificial intelligence today. With Vlad and Yoler, I designed and wrote this text, also mentioned by Satinder, called the no-scope manifested. That is our actually attempt to develop a pedagogical interface to try to struggle to explain the complexity of AI in simple terms. It's very difficult. I don't think that we made a fantastic, complete, ultimate job, but at least is an attempt in that direction. And to simplify this complexity, yeah, it's been difficult. It took like, I think, 3 years to put together this manifesto that is a diagram of each component of a general machine learning algorithm today, step by step, going through the machine and trying to make a detailed map. And what we reach as a conclusion, as a sort of very pragmatic and empirical conclusion, is that today artificial intelligence is not about forms of alien cognition or form of super intelligence, but is basically, modestly maybe, just an instrument of knowledge magnification. So the term no-scope refers to this, refers to a sort of telescope or microscope for knowledge, to magnify patterns, to magnify what we discover in nature. And this is also not an original idea of ours, it comes from Leibniz, that wrote something like this few centuries ago. I quote Leibniz here. And Leibniz was talking about his idea of calculus ratiocinator, the idea of writing a logical language to encode all human knowledge. And Leibniz wrote about this. Once the characteristic numbers, this sort of logical code that he wanted to use for human intelligence, once the characteristic numbers are established for most concepts, mankind will then possess a new instrument which will enhance the capabilities of the mind to a far greater extent than optical instrument strengthen the eyes, and they will supersede the microscope and telescope to the same extent that reason is superior to eyesight. And for us, this quote of Leibniz was a good way to describe also what is artificial intelligence today. an instrument, not an autonomous being. But instruments always come with their aberration. I mean, especially optical instrument. If you keep, if you keep on using the idea of the metaphor, the analogy of the optical instrument, you always have mistakes, errors, aberration in the machine that you want to use. And this is an important aspect that I think that is overlooked by everybody dealing with AI today. You don't see a lot of discussion on the limit, the limitation, the fault, the biases. There is actually a huge debate on bias, on algorithmic bias, on gender, race, and class bias that is amplified by machine learning. But one of the things we forgot to mention is that there is never a paradigm of intelligence without a paradigm of errancy, without a methodology of error. But this is another discussion, probably. We don't have time to go into detail today. So for Vladan and me, machine learning or AI, also on the other side, try to contest some kind of obscurantist reading, is not about a new dark age that is brought by machines that are unable to understood by these new black boxes. It's not a new dark age, but is an age of diffracted rationality, we say. And more in general, for us, AI is a new regime of truth, of scientific proof, of social normativity and rationality, but often something that takes the shape of a statistical hallucination. And I like this term to define the quality of AI today, statistical hallucination. And another thing that I would like to stress, and I don't know how much time I have left, Satinder, 1 minute, I don't hear you, 1 minute probably. Okay, 1 minute. Yeah, another thing that I would like to stress, speaking of artificial intelligence today, we are still at the stage of an experiment. So it's incredible that we use neural networks, they are very powerful, but we don't have a theory of learning. We don't know why they operate so well and they fail so badly. So we are more or less in the same stage in which we found the steam engine in the 19th century that caused the Industrial Revolution. When we design, or when some people designed the steam engine, we didn't have thermodynamics. Thermodynamics came after, basically, to describe what the steam engine was doing. And today we're still in this sort of experimental phase. So when we talk about artificial intelligence, we should talk about artificial experiments, probably, of intelligence. And on this, I would like maybe to stop here and to, on this note, on the fact that, yeah, we still inhabit an experiment with all the potentiality this experiment may have. This is our website, if you want to check it. It's a very long and detailed essay. I hope, Satinder, I finish in time. Thanks.
That was a wonderful, wonderful talk and really explained to us how AI actually works, and a wonderful point that we need to be more specific about what we mean when we say algorithm, which algorithms. And I was very intrigued that you asked a beautiful question in your article, which I think captures all of this. You asked, can a machine think? You said, if we're going to ask such a question, then maybe we can ask, can a statistical model think? Can a statistical model develop consciousness, etc.? I was wondering if you, so this is something that I think is, I like the way you frame and ask us to rethink, reshift the ways in which we're thinking about the intelligence itself. And you give a wonderful illustration that when Greta Thunberg warns that we should listen to science, she's saying, listen to the statistical models of climate science. And of course, your work goes, we will continue this in the discussion. Your work on extractivism is really fundamental and important as a way of framing what's going on in our relationship with machines. But we'll come back to that later. Thank you very much for this wonderful, rich discussion. Now I would like to ask Sabine to please give her wonderful talk. Great.
Hello, thank you very much. I also would like to thank the organizers of the webinar for the invitation, and especially So and Nikos. It's a great pleasure to participate and talk on the topic of art and AI from my perspective as a curator, and I will present examples from two exhibitions, previous exhibitions at HEC, House of Electronic Arts in Basel, Switzerland. And it's nice to connect with Matteo here, because for one of those, Entangled Realities, he has contributed an essay to our catalog and also gave a keynote, the symposium that we were staging. So I hope you can see my presentation. Yeah, okay, good. In 2019, together with Boris Magrini, I curated the show Entangled Realities, Living with Artificial Intelligence. By presenting a few examples from the exhibition, I would like to show how machine learning is used today as a tool for designing new worlds of images and sounds, and how artists working with artificial intelligence evaluate the creativity of the machine or define its authorship. Many works in the show illustrated the processes of machine learning that we heard about now, also from Matteo, and they gave insight into machine methods of cognition and perception, which we otherwise only experience as the already mentioned black box. Entangled Realities focused on the reality building effects of AI and its use as an artistic tool that creates new and unpredictable visual worlds and artifacts. Through the interaction with intelligent algorithmic systems and the empowerment that we already give to machines in various processes and areas of life, new intertwined realities are created. That's also why we choose that title. The works represented in the exhibition showed how these algorithmic networks see the world and also create the world. Our living world is shaped and co-designed by AI, and it's important to consciously shape this new interaction between man and machine. German artist Mario Klingemann has been working in this field of art and AI for years. He writes the software for his works himself and trains so-called generative adversarial networks to create desired but also surprising aesthetic manifestations through artificial intelligence in real time. When asked about the creation process, Klingemann's answer is clear. Quote, "For me, AI is just one tool in a long history of tools that was bound to be used for artistic purposes. But I would say I use AI as a tool, and the works that I make with this tool are mine and not a collaboration. In the same way, I would not call a hammer or a piano a collaborator." In his work Uncanny Mirror that you see here, the faces of exhibition visitors are on focus. Klingemann trained a generative adversarial network with images of human faces, and so one encounters one's own image in real time, as interpreted and seen by the AI. Based on the training database, the AI constantly develops new portraits in real time, an endless stream of pictorial inventions whose aesthetics are based on the algorithmic decisions that Klingemann made, but which take on a strangely surreal and eerie character through the constant appearances of past or future images. And it was quite nicely when Mario was there to install the piece, he showed me when he took certain tweaks in the algorithm that kind of the aesthetic representation changed immediately. Musicians Holly Herndon and Matt Ryhurst address the transformation of society in their music and explore the influence of digital tools and new technologies on vocal processes. For 2 years, they have been dealing with artificial intelligence based on neural networks and have expanded their ensemble, which consists of several vocalists, to include another artificial voice, an AI they call Spawn, or also their AI baby. They feed this computer with audio files, and it learns language based on the voices of its parents, another term that or metaphor that the artists are using, which the system can reproduce. Spawn learned to improvise and create abstract compositions based on acoustic information and musical and vocal inputs. The image I'm showing you here shows a video installation that documented the first training session when Spawn interacted not only with the ensemble, but also with a larger audience. Herndon and Dryhurst emphasized the opportunities that AI offers as a new musical tool for the synthesis or resynthesis of sounds that exist or did not exist in the world. In their own words, they are looking for, quote, new symbiotic ways of human-machine collaboration, new ways of creating together, quote. We as curators, Boris Magrini and myself, we commissioned the Swiss artist group Fabric CH to develop a software for the exhibition in which an artificial intelligence develops various scenography scenarios for the exhibition. For this experiment, we provided practical specifications such as number of elements from our wall system, available lighting, sound and technical requirements of the works. In addition, we gave certain criteria that linked the works with respect to different themes. I show two different perspectives from the renderings the AI made. Now this is one, and you can already see, please look carefully at the wall system, and you see the strange placement and fragmentization. And here another example. What happened was that the algorithm fragmented everything. Wall got broken up into parts, into the single elements. Wall paint was used very erratic, which was actually quite inspiring for us. We did not build the exhibition according to a suggestion from the algorithm, but we changed the placements of wall and generated a quite unique and dynamic structure for the show. So working with AI was doing the trick in that context. And the feedback we got from our visitors was that it was kind of the best scenography that they have experienced at HEC so far, which is kind of remarkable. The last image here shows how the work itself was presented within the show, with the system running and continuously processing new versions of a scenography we could have realized for entangled realities. The question of authorship in the field of AI art was clearly assessed by the artists. An algorithm only follows a set of rules or a certain trained behavior. At the same time, AI systems are seen as a new tool in the artistic palette with image inventions that are also able to surprise the artists themselves. So in a nutshell, it can perhaps be said that AI cannot be an artist, but that it can produce art. Another show I would like to mention is Real Feelings, which I curated together with Ariane Köck and Angelique Spannings. Emotions are the core of human experience. They differentiate us from machines, but these borders seem to erode. The international group exhibition, which just closed a couple of weeks ago, explored the rapidly changing relationship between technology and emotions. An important aspect in this exhibition has been the use of AI to recognize, measure, and manipulate our emotions. Right at the entrance of the show, visitors encountered Vibe Check, a piece by the American artists Lauren Lee McCarthy and Kyle MacDonald, which had been commissioned for the exhibition. The piece, as you can see, consists of a series of screens on which visitors are portrayed and certain emotions are attributed to them from an AI system. While walking into the exhibit, visitors encounter cameras, and you see the little purple box in the corner. And there was a camera embedded connected with an AI system. So they were filmed, and there were the AI system registered the interactions they had with one another. So it was not about following one particular person, but always looking at the social interactions of the visitors. And a very nice example you see here, unfortunately, it's too bright, but in the image, they make us feel contempt. You can see that the AI could not differentiate between real human visitors or images on a video, for example. And here it was registering one of the videos. So the system analyzed 6 universal emotions, and at the end of the visit, visitors experienced their own image with their respective emotions while walking around the exhibition, judged by a machine learning system. French artist Justine Aimard's video installation Co-AI Existence addresses questions of coexistence and cohabitation of humans and machines. In her poetic work, The Robot Alter, developed by the Ishiguro Lab in Japan, reacts to the movements and verbal contact of a dancer. There is no common language yet, but tiny points of tactile encounters and forms of contact. It is through touch and encounter they appear to create an emotional bond, and show a short video clip where you can also see the data release, how the neural network is actually processing the environment. I leave it here. A new commission by the Swiss artist Simone Nickil, Elephant Shoes, explores how artificial emotional intelligence is used for hiring today. Set in a bathroom, the work follows a character preparing for an upcoming automated job interview. The work reflects on these developments, but makes us aware of the limits of objectivity of these automated systems and their categorization of deep, personal, and delicate matters of emotions. The title of the commission points out that all is not quite as it seems, because elephant shoes is a phrase which theory often misinterprets when the words "I love you" are spoken to it. And I also show a short clip from that piece.
Automated lip-reading systems often interpret "I love you" as elephant juice. How did such deep emotion learn to behave like a bat? It does not tell what it is like for a bat to be a bat. It does not help to imagine having very poor vision and perceiving the world through reflected high-frequency sound signals. Is this what it is like to be a machine learning system? Restricted by its creator's imagination? Restricted by human imagination?
I also leave it here and just mention that the bat is a reference to the philosopher Thomas Nagel, who wrote that book in the 70s, that we will never know how it is to be a bat. So my last example is a photo series, Happiness is the Only True Emotion, by Swiss artist Clément Lambellet. It shows the limits of AI and emotional face recognition software. Currently, the only emotion that has the highest accuracy rate in facial recognition using AI is happiness. The possibilities of AI may be considered phenomenal and potentially capable of solving the world's problems. But as Lambellet shows, they are rudimentary and biased by the information given to it. And here you can see the same person. It's images from a database that is used to train AI. And on the left side, you see the expression of fear, in the middle, happiness, and on the right side, sadness. And you can see maybe the glass overlay on the images where you see the ratings of what the AI recognized on these universal emotions. And you can see only with happiness, it's nearly 99% sure that this is what it's seeing. The examples showcase how artists are reflecting current societal developments. They make us aware of the limits of objectivity of these automated systems and their categorization of deeply personal and delicate matters of emotion. I would like to end with a quote by Sherry Turkle on the use of the word intelligence in relation to machines. Quote, intelligence once meant more than what any artificial intelligence does. It used to include sensibility, sensitivity, awareness, discernment, reason, acumen, and wit. Effective is another word that once meant a lot more than any machine can deliver. Yet we have become used to describing machines that portray emotional states or can sense out emotional states as exemplars of effective computing, end quote. As Turkle points out, the meaning of effective has changed. Once used an expression for emotions outside technology, it has become a term that is joined to technology. By effective, technology still tends to narrow feelings down to clear, measurable data and recognizable patterns, whereas to us humans, the emotional always is more messy, bodily, and subjective experience. Emotions make us realize our vulnerabilities, which we control through training and civilization, including technology as a tool. Thank you very much. I end it here, and here's also some information to get in touch. Thank you.
Thank you, Sabine. That was a wonderful, wonderful talk, and it was great to actually see these images of the various projects and shows. It is so striking how, whilst revealing the limits, that art can also find a way to be creative with those limits. And it's serving a function to, it's allowing us to see what AI actually can do. Wonderful discussion on its limits. I'd be intrigued perhaps later in the discussion to reflect on how this creativity that the arts can bring to how we work with these limits and what they, you know, this unexpected fragmentation and the novel creation of something that's new and we couldn't have seen relates, you know, Matteo refers to the extension, augmentation of the human, the instrumentalism of technology. And here we have this creative force that art brings. Be nice to have some, be interested to see how we can bring some of that together later on the discussion. Thank you so much. That was brilliant. And now we have our respondent, Sey Min. So I'm looking forward to hearing what you have to say, Sey Min.
Okay, great. Okay, thank you for your presentation. It was really wonderful and very inspiring. But at the same time, I had an exhibition like 2 years ago about like which is called AI Entirely on Us. It's like a questioning, like is this technology is for all? It seems like it keeps saying the AI is for all, but who are the all? Like, I feel like I'm not in that circle because the technology is too difficult to learn. And for example, like artwork, I can see and I can understand what it's talking about, but I don't really understand how it works because technology too, it's too difficult to learn. So as an artist, I also use like many like algorithm system using the machine learning system such as GAN and some like a dimensional reduction system to see the data in there. And also I like the Matteo's mention pointing that we are on the stage of experimental at the stage, which means we cannot answer any question maybe at this time, but we are just keep trying how AI we can work with it together and what kind of creativity actually we can get it from the AI system. So after like I don't know how actually I can respond to your presentation, but I would like to question to you both speakers about like two different things. The first one is there are many people are trying to lowering the floor because this technology is too difficult. So as an artistic tool, AI has given us more opportunity to expand our creativity, of course. We can see things in different ways with AI, of course, just like the Matteo mentioned about that. We can see deeply inside of the system and see different things is happening there. But at the same time, as I mentioned before, it's a high tech, very high tech, and make it impossible for many creators to understand the technology of AI. And there are several frameworks for lowering the floor, such as like ML5JS and TFJS and Teachable Machine from Google and Lob from the Microsoft. People are trying to make people use AI without coding, but still it's very difficult. And some online course such as ML for the artist by Gill, but it's all English-based one, which means if you don't speak English, it's very low accessibility as well. So I would like to question to you both speakers about like, do you see these frameworks really help people to narrow down the skill gap? Or if it's not, how can you solve the problem? How can we narrow down the gap between high technology people and regular people here, just like me?
I think it needs to be the
Okay, yeah, it's
it needs to be the host that allows us. Well, maybe I can start. I think that's why it's important for me to, or that's why we did that show, Entangled Realities, and also the feature on real feelings, to make a general audience aware. And a huge part of the exhibition also has been an educational program, work with AI. One was kind of really made for practitioners and designers that we realized together with the academy and a company who were really working together, explaining the tools. Another one was more for a general audience where we also showed, based on the work done by Adam Harvey, how you can, for example, hide from facial recognition software by, for example, using special makeup that irritates these algorithms. So I think an important aspect that I would like to mention here as well is that the effects of AI are not only technical one, but it's social effects that we have. So I think it is important that we try to understand the mechanism. That's why it's important what Matteo does to really, explain in detail how these workings are. And I think it's something, changing the society. So we cannot just leave it to technicians to take that decisions for us. And I think it's very important that also at universities, training programs start that students are learning also to use these methods in their design processes.
Okay, and I have one more question to you. To understand the artwork driven by AI, do we have to know that mechanism behind of that?
I think that a lot of the artworks that I was showing, or more that there are many more, of course, in these exhibitions. But curatory, I really tried to make people understand what they see and what they experience, kind of to open up what we call these black box. For example, we had a series of works by James Bridle where he really showcased, that, or what you saw in the short video clip by Justine Aymar, that kind of like processing of data is fundamentally different to what we are. And we had a very nice piece by Sekyung Kim, a Korean artist, that was inviting the audience to train a system on the understanding of universal emotions. And it was quite, and of course also show them the importance of the training data. It's actually the information that we put into the system that creates the output fundamentally. And some people were taking it really seriously, were really coming up with elaborate descriptions of emotions, and others, of course, were, making fun of it. But that's human nature, I guess.
So we have to know that we have to at least have a basic understanding of AI to enjoy artwork driven by AI, because it's talking about like all the mechanism behind. So if I don't understand the mechanism behind, maybe I'm not able to enjoy the artwork. That's what I'm thinking. Okay, thank you. And Matteo, can you tell me about your opinion about the lowering floor?
Yeah, this is an important problem question. I think in the 90s, we had a similar problem. We call it digital divide. I mean, also the problem that we had in accessing the digital sphere, in actually handling the new digital culture. Today, we have something like we could call a cognitive divide in our problem in accessing the complexity of AI. But I think it's just a temporary problem. I think our grandchildren, next generation, they will study machine learning at school, primary school, like they want to do in Finland, in China. There are many countries today they want to. Recently, also the German government asked all the university in 2020, probably 8 years after the beginning of the deep learning revolution, to have courses or to have a kind of agenda, educational agenda on machine learning. But for me, it's not a problem to have a sort of technical understanding. It's I found it very conservative, just to teach machine learning as a technique, because also as a teacher, I'm interested that my students, that myself, understand the knowledge model that AI implies. So which knowledge models is AI enforcing, and which are the other knowledge models on this planet? So I think there is also a crucial colonial issue when we just focus on artificial intelligence as the only knowledge model we should study today. I think this planet is rich of many different knowledge models. And this is an important thing to keep in mind. So the technical problem per se is really slippery if we just focus on the technical problem per se. And today I would say, if you want, we could now discuss and explain how a neural network works. It's not that difficult. It's really simple. The intuition, it sounds a bit black magic, but it's really simple. If you want, we can do it like in 5 minutes. But I mean, for students today, there is also likely a new discipline emerging called critical AI studies that try indeed to keep all the political, cultural, aesthetic questions within the technical question. So I think that today students have a lot of tools, and younger generation, new generation will be more familiar with this technical novelties.
Yeah, right. So maybe this is my problem, or maybe this is our problem, because we just started from here.
No.
Yeah, okay.
I would say sorry, Sey Min, it was also my problem, because 5 years ago, I had no clue about artificial intelligence in the form of deep learning. We were, we were familiar with neural networks a bit, but then it was, of course, a sort of industrial revolution that came to us, that entered our university department. But the neural network is something very simple, Sey Min. It's just, on one side, you have like a large input, an image, And on the other side, you have an output that is just binary, and they have to say that image belongs to a class or not. So it's very simple. You have two numbers. On one side, a big number or many numbers, and on the other side, you have 0 and 1.
So for the classification,
Your driving car on the street does that. It takes a large number and try to detect a simple class, 1 or 0.
Right.
We can go in more technical. It'd be nice to discuss, the logical form behind this.
Right. I totally agree with your point that maybe younger generation, they are more familiar than us. So maybe they have no problem with understanding AI-driven artwork. It might be different from my age, my generation. So let me ask one more question to you and Sabine. So because the old-trained model is very solid and very for me, it's like a very concrete architecture, which means engineers already tested the architecture already for a long time. So I don't much see how my creativity actually get into the model, but I only can see I can control data creativity because by controlling how augment data and how to expand the data sets. So what do you think about that? How we can apply creativity in this system?
Thank you for Nabi.
Okay.
Thank you. Thank you so much. Thank you.
Okay, thank you.
Bye.
Okay, bye.
Everybody.
Okay.
Bye-bye.